In this video, I'm going to do Krugman and Wells Microeconomics, page 127, number 8. So I've copied the image that they give you here onto this video. But before I get started with the problem, I just want to call attention to and explain why we have moved now from a demand curve that looks very step-like, so, you know, something that looked more like this, to a continuous downward sloping demand curve. And the reason has to do with the number of consumers or the quantity demanded. So I have 3 images to the right there. So in this first image, I have 4, you could think of it as, the quantity demanded is 4, or you have 4 consumers, each demanding 1 item. And you see that, it has this very familiar step-like look beneath that line, and that if I were to place a line sort of on top of these triangles, that I would have a pretty, a gap in that sort of pocket between the top of that bar and the line that I drew. And then as I add, though, more bars to my graph, I see that that area underneath the line actually diminishes. So if you look at number 2, I've added, a few more items demanded, and this area is getting smaller. So this area between the top of the bar and the line is getting smaller. And then in the third picture, I have actually drawn 17 bars, and you can see that this area is getting even more small. So this becomes relevant when we think about the consumer surplus. So let's take this blue line that I've drawn here in the third figure, and let's say that this is the market price for an item. So maybe it's, I don't know, $10, and we want to calculate the consumer surplus. Well, what we've been doing is to say, okay, well, let's calculate the area of the portion of this bar that sits on top of the market price. So we've been calculating the area of each one of these rectangles and then adding it up and getting the total. But the convenient, this starts to get a little bit annoying as you add more and more bars, but the convenient thing about adding more and more bars is that the area in that portion is actually beginning to get close to the area underneath a line that sits just on top of all of those bars. So at some point, and that's going to continue as you continue to pack in bars, you're going to continue to get closer and closer and closer to just this continuous purple line that's sitting right on top of them. And so at some point, when we have enough consumers whose demand we can represent the demand curve as just this continuous downward sloping curve, like so, as we've been given, and we can calculate the consumer surplus as the difference between the market price and that downward sloping demand curve. So it's now typically going to be not adding up the areas in a rectangular portions, in that sort of stepwise graph that we've seen, but rather it's going to be the area of a triangle. So for instance, in this problem, we're told that, I guess this is an amusement park, and this is the price per rides. And we're told that the market price is $5 per ride, and we want to calculate the consumer surplus. Well, accordingly, the consumer surplus is now going to be this area between the demand curve and the market price. So we need to calculate the area of this triangle. So if you remember, the area of a triangle is equal to 1/2 the base times the height. In this case, we have a base of 10, we have a height of 5, so that when we plug that in, we have 5 times 5, which is 25. That is going to be our consumer surplus. In part 8C, we are asked to think about the situation where the consumer, the price ends up of each ride gets lowered to 0. So that's going to be now the market price is going to come all the way down to the end there. And we're asked to consider what the maximum admission fee could be that Fun World could charge. Well, again, no different. We're going to think about the case of what the area is underneath now this entire triangle, because this all represents how much consumers would have been willing to pay above the market price, and that is going to be the price of admission. And so we just now need to employ our formula for the area of a triangle. Again, is equal to 1/2 base times height. In this case, the base is 20 and the height is 10, and so I have a consumer surplus of $100. So that means that that's the maximum that they could charge as an admission fee, assuming that the price per ride is $0. So you just pay an admission fee, you get in, and then you don't have to pay anything to get on the rides.